Hello everyone, my name is Tom. This is Simin, this is Yotam and Vibhaa. We actually have another group member, Steven, but we're going to talk about our Bitcoin script IDE project. So in the presentation, we'll first go over the go of this IDE and then talk about existing work that other people have done before. After that, we'll discuss the methodology that we used and then give you a demo of the result, which is the website that we built, and then talk about future work. For this project, we wanted to build an IDE for the Bitcoin scripting language, and it's supposed to be as user-friendly as possible. By that, we mean we want to have these features. So it has to have syntax highlighting and autocomplete. For example, for somebody who's not very familiar with the language, this can help them code and test their code. And also assembler and disassembler. So you can use the IDE to code some script, but when you actually send this to the blockchain, you have to send the assembly code. So that's what it's used for. And also, it would be helpful to have a debugger and support visual execution. So the user can step through the code and see what's going on the stack, since the scripting language is a stack operation language. I think that's the name, or stack programming language. And Simin is going to talk about the previous work.
So the closest thing to previous work we could find was this, which is not very pretty and not very user-friendly. You have this one text box where you can copy and paste your script, and you try and run it, and it gives you this nice execution stack that is not actually representative of what the actual script for the stack is. It's just the execution of it, and it gives you back if it's a successful script or not. And that's really all that it really supports. And so we wanted to make a more user-friendly, understandable script. And so to do that, we used the ACE JavaScript framework for autocomplete and highlighting. And and then for the assembly translating and the stack visualizing and debugging and interpreter, we used JavaScript and jQuery, and then crammed it all into a nice HTML for the IDE. And then our demo.
Yeah, so we'll go into the demo, which Tom has very nicely posted for us. We've managed to implement most of the opcodes in the Bitcoin language. So for example, simple arithmetic ops work fine. Hopefully show you what's happening on the stack, and that will hopefully push 3. Thank you. Some of the crypto operations are also support. All of the crypto operations are supported. So for example, if you were really, really curious about the hash of 123, you could in fact find that out.
Oh, you should have put the opcode in the brackets.
Oh, yes, that's true. Sorry. Sorry, the 291 is because that's in decimal, and the input is in hex. And so that's a verifiable hash if anybody really is questioning us enough to want to check that. One of the more intriguing challenges was control flow. So for example, I'll put this in scripts are typically one line, but I'll put it in a way that's kind of more human readable. So this should hopefully push 2 at the end. So then it checks if the top stack value is equal to 1. If so, it pushes a 2, and then that's the end of the script.
Do you want to try to show a Z number?
We also have checking for valid but ultimately unsuccessful transactions. So for example, one that ends with a 0 at the top of the stack. And so you have a little, I don't know if you can see, but there's a little bar over here. It turns red, very angry type of red, and tells you that your execution didn't work. There's also some pre-processing that happens to check if the control flow makes sense. So for example, if you don't have an end if statement, everything will in fact just be refused. It'll tell you that your script's invalid. One of the things we supported, pay-to-script hash isn't fully supported, but we got most of the way there. And so for example, essentially now works as a 2-step process rather than as a 1-step process. So if you wanted to find out the hash of a script, you put it in arrow brackets. So for example, example, a good one, if you wanted to find the hash of the script that we started with, you would do something like this. So that'll push the entire script onto the stack and then return the hash. And then you can use that for your pre-descript hash execution. And I think that's all we planned for the demo. There are, pardon me. There are a few other features that we mentioned. So the assembly disassembly thing works over here. If you want to check a very simple script, you'll see the binary, which gets sent to the blockchain. Very recently, we had a feature that allows you to kind of upload or download a script over here, and a few other options for various visual interests. Yeah. I'll talk about the architecture of the solution.
So this is a high-level picture of the different modules that we use to implement this. So the central unit is the parser, which basically generates a series of tokens from the user input. So the user input comes from the HTML interface, and then the parser basically sends out a series of tokens. So if you want assembly, those tokens are converted into assembly. The syntax highlighting unit also uses those tokens and identifies which which kind of token it is, and depending upon that, colors it appropriately. The interpreter takes each of those tokens and then uses a step method to basically do one or facilitate one operation at a time. So each operation is basically translated into a series of pushes and pops, which is run by the stack module, which is both responsible for maintaining a main stack and an alt stack. The alt stack is not shown in the visualization because it's involved only in one or two operations. And the stack module is also responsible for the complete visualization part of this. So you basically start here, go all the way there, and finish there.
So also, just to explain how the assembly part works, in case you don't really know about how Bitcoin script translates to assembly, in Bitcoin, every opcode represents 1 byte and it has a corresponding assembly or hex number, which is a 2-digit hex number. So for example, op-add corresponds to 9.3 and op-equal corresponds to 8.7. And constants are represented in opcode or in assembly with this extra byte at the beginning. So if you see this constant 9387 AB, there's no way for you to know whether this 93 corresponds to an opcode 93 or actually is just a constant. So the way this is translated to assembly is we just add the number of bytes of this entire constant, which is 3, since it has so we just add 0, 3 to the beginning, and then this represents the constant in assembly. And that's actually how this is done in blockchain. So for our JavaScript code, when it sees a script like 89 ABCEF, ABCDEF, I think I meant to say ABCDEF, but it doesn't matter here. And then op hash 160, op negate. It first passes into a series of tokens, so 3 different tokens, and then tries to see if each one is an opcode. So for the first one, since it's a constant and it has 4 bytes, we just convert this into 04 and then the constant itself. And then 160 or hash 160 is A9, negate is 8F. And then you just combine everything together, and that's the assembly. So when you convert from assembly back into the opcode, you also follow the same protocol. So first we start from the left and see 04. So then we take the next 4 bytes and translate this as a constant. And then the next one is A9, which is a hash 160, and then 8F, which is negate. So that's how it works. And Yotam is going to talk about future work.
Yeah, so one of the problems we had was in implementing checksig, only slightly important Bitcoin scripts opcode. The biggest issue is that checksig requires hashing the enclosing transaction, and in this particular scenario where the enclosing transaction doesn't exist, that doesn't really make sense as a concept. One way to do that would be where you can ask the user to input some data, but that's very work intensive for the user. So for right now, what it just does is it returns true. So no matter how invalid your pub key or your signature might be, it's still true. And then we could support or streamline pay the script hash, which would be cool. I mean, well, we've already taken care of hashing the script. The only thing that would be required is after all of the signature after all the verification is done, is to then run the script itself, and that would be it. Yeah, that's essentially it.
Cool. Really cool. Yeah, I thing where I built something where you could compile script to JavaScript, and so I was going to ask about the check sig thing, because it's really weird that like it's the only like stateful opcode. I mean, it's not like truly stateful, but it does require that you know like the inputs and the outputs of the transaction.
Yeah.
I'm curious. So when you guys did debugging, did you guys do like breakpoints or anything like that? Or is it mostly about being able to step through it?
It's mostly about
Yeah,
being able to
that's
step
cool.
through, especially because, I mean, scripts tend to, I mean, in theory you could have like this thousands of opcodes long scripts,
Yeah,
right? But
on
they're going to be so
phones,
small that setting a breakpoint's not really worth it.
Yeah, I was just curious how like
Yeah. So you can either step or you can just run through the entire thing.
Are there no opcodes with really low numerical values so that you can distinguish between what's a byte count and what's an opcode?
I think the opcodes between 0, 1, and 75 are reserved just for constants. Everything else is after 75.
75 decimal
Or
75.
yeah,
hex.
I think decimal.
I thought it was hex.
Okay, maybe hex.
there's some limit to the size of constants.
Yeah.
Yeah, I mean it's enforced by that. I was wondering if it's
It's probably hex.
Yeah.
like 75 hex. So that's half the opcode space gone.
A lot of them are just it's a very
Yeah,
it's kind of eccentric. Like a lot of them are really not necessary. They just seem to be there for fun. Like you can rotate like literals. It's not useful.
There's a rotate, there's a swap that does the same thing,
Yeah.
Yeah.
except for different numbers.
Did you guys think about the challenges of having something that would check if your script is standard or not?
No, I don't think we did. I think that the extent of the validation checking we did is to make sure that there are some opcodes that fail a script if they exist at
Right.
all, like verif and vernative.
We also had some problem knowing what a standard script
Yeah.
was.
And it, and it
There's
can,
not a
can
lot of-
change.
Yeah.
That's one of the problems with Bitcoin script is there's basically two languages. There's the actual language plus the what's considered standard language.
Harry.
Just like one feature suggestion you might want to add in would be templates. So pretty much just like a feature to take the standard transactions and put in something where you can fill in the blanks.
Yeah.
Yeah, that's good.
Is it open source? Is it available for us
It's
to
on
play with?
GitHub.
So
Yeah.
Cool.
In the report, we also had the link.
Yeah.
Yeah.
And it runs entirely client side.
Yeah.
If you
Cool.
want to
Thank you, guys.
contribute.